Hello everybody and welcome back to video 4 in this tutorial series on PostgreSQL clustering. And we've looked previously in 3 videos at things like an introduction to PostgreSQL as a database server. It's a great system, it's open source, and things that would normally cost you a lot of money on a licensed system like Oracle or SQL Server, you're getting right out of the box for free in PostgreSQL. So for those sort of smaller businesses where you don't really feel like spending tens of thousands of pounds a year just on your database, this is a really good idea for you to create what you need to create without worrying about how much it's going to cost you. So we're looking really specifically at how we set up a highly available system using a number of PostgreSQL database servers. We're going to have one primary server, we're going to have 2 secondaries, and we're going to show some scenarios where we can fail over and such like. But in order to get there, we want to actually look at backups and using Barman, which is the backup and recovery manager tool, which isn't actually part of PostgreSQL itself, which is a shame because I think it works so well with it. It would be nice if they just included it within the PostgreSQL client libraries, but that's how it is. A Barman is effectively a tool that automates a lot of the things that you would otherwise have to do manually when you're setting up backups in Postgres. So really all it's designed to do is hide a lot of the complexity. It doesn't necessarily do a large amount on top of that because that's not what it's designed to do. It's just to give you that sort of slightly easier touch point when it first comes to configuring Postgres and making sure you're getting backups at an interval that you want, and you know, all of the various options that you need, like point in time recovery or whatever, are all part of those configurations. So the 2 main jobs that Barman does is, the first is just to stream data, just like it's a replica database. Now you will install PostgreSQL client tools in order to use some of this functionality, but Barman is not running a PostgreSQL cluster. So it's not actually replicating the data onto a running cluster like a normal replica would. But by doing that streaming, we get to keep the logs. Now, we could say as soon as they're written, but of course it's slightly different in Postgres. These logs, these write-ahead logs, or WALs, are written to before the data is committed to a table. And that just really helps with crash recovery, because we know that the logs always have the latest data in them, even if an error occurs while writing a main database table. So the first job of that is sort of copying those over, and obviously what it can then be used for, well, not obviously, but when we look at replication manager in the next video, we will see how rep manager can use Barman as a source of those log files in order to create replicas, and that just saves us having to go back to the primary all the time and asking it to send over, you know, tens or hundreds of gigs of stuff to set up a new replica. So that's really cool as well. And then the second thing that we can do as well is we can set up, like I say, those different intervals, different retention policies and things, so we can decide how much data we want to keep, how much we want to automatically delete after a period of time, whether we want point in time recovery or whether we just want base backups to give us a much kind of simpler and broader backup policy. But it just works. It's dead easy to do. We'll see. The setup part of this video is probably the quickest part, but I think what's important is we start really sort of taking a step back, and you might be thinking, oh my goodness me, here we go, it's going to be one of those long boring talks. And I think the problem here with jumping straight in with setting up backups is that it would be quite easy. You could probably spend an hour setting up backups and you'd be great. You'd have a number of backups being stored on a server. You could kind of get that warm fuzzy feeling that you're going to do really well in disaster recovery. But of course, having backups and being able to use those in an actual scenario, a disaster recovery or business continuity scenario, are 2 very different things. And the danger is that we invest time in areas that are not really so much of a risk, but then we're not really addressing the issues which are really going to come back to bite us if something goes wrong. So by spending a little bit of time talking about risk analysis and recovery times, recovery points, just hopefully helps us sit down and think and plan a bit more before we jump in. We might find that there's certain things that we don't need to do. We might find that we already have a system in place that will resolve some of the things that we think we're fixing, but we might also identify a big gap in something else, and that might not even be a technical gap. It might be an organizational gap or something to do with, you know, part of the process itself. But the first thing we just need to define is the recovery point objective and recovery time objective. These are very common definitions that you'll find in information security, so you'll often hear people talking about these. And quite simply, it's a little bit confusing because really point means point in time. So it's really a recovery point in time and a recovery time. So the first one of these is, which point in my data can I recover if the worst happened in my production system? So let's say my database server caught fire. I lost the current live database and all of its data on the disk all got burned. What is the most recent amount of data, the most recent time that I can go back to and say, right, I've got data from 5 minutes ago or an hour ago or 24 hours ago or whatever. Now, depending on your company and your risk appetite and your system, you might say, I could accept if the worst came to the worst and a really unusual problem happened, I could accept losing 5 minutes or 10 minutes or an hour. Maybe I can't accept losing 2 hours. Maybe that's too much data. On a high traffic system, that's a lot of information that could potentially be lost. So that's why thinking about the recovery point objective is really important, and why it's very likely to be different in different systems. So we don't choose a company-wide RPO. That would be wasteful because it would have to be the level of the most high-risk system. There will be certain websites that, you know, really won't matter. You don't have to go crazy. An hour would be more than enough. So that's one thing. And the second thing, the recovery time objective, is perhaps something that we've overlooked a little bit, which is to do with how long is it going to take me to bring this offline system back online again. So whatever's happened, whether you have taken the system offline because of a problem that you've seen, an attack or something like that, maybe it's gone offline because of a hardware failure or a network failure, or maybe your hosting provider's gone offline. Maybe you know how long they're going to be offline for, but most of the time you don't know. How long is it going to take you to get back to a point where your customers and your users can use your system again? Again, there'll be a different appetite, and in some scenarios that, you know, the amount of time could be very, very expensive. If you've got something like a stock market trading application, I suspect that, you know, every minute's probably costing your business $1 million or something. So having a really short recovery time would be really important in those scenarios. Whereas in a lot of scenarios, probably the recovery point is going to be more important. I could afford the system to be down for an hour as long as I've only lost 5 minutes worth of data in the process. An hour is not necessarily unreasonable to get it back online. But that's all very fluffy and theoretical. So I want to kind of look at an example. And here we're going to talk about recovery time objective. How long is it going to take us to resolve a problem? So this is a scenario. You get a call from someone in the IT department saying that one of your applications is not working, but they're a bit worried since a member of staff has just told them that they ran something suspicious on their machine from an email. You have a little check and you go, oh my goodness me, the data in our database has been encrypted. Okay, so this is let's just assume it's a ransomware attack. It doesn't matter if it is or not. Your database is going to be unavailable very quickly, and your data is basically getting destroyed as you're sitting there watching it. Well, my first question to you is, would you even know that has happened if the IT department hadn't called you? You know, do you actually have a suitable level of health probes, looking at things like excessive CPU, excessive disk access, things that are out of the ordinary for your system? Do you have something that's checking the data in there? Is, you know, even if it's just checking a random row in a random table, is there just something in there to say that if this ransomware hit, I want to know immediately? But how does immediately work? Are you going to be emailed? Are you going to be called? I don't know about you, but I don't always see my phone ringing. I don't always have it on me. My emails, work emails, don't come up on my phone. So for me, that's not even necessarily good enough, but maybe in your business there is a team, an out of hours team. Maybe you cover weekends, nights, whatever, but these are sorts of things you've got to be thinking about. Okay, you might shut down the server, but is that right? Are you allowed to shut it down? Is that going to take out another load of systems? Do you actually have any backups? Do you know if you have any backups of this database? Maybe somebody else does, but maybe they don't work there anymore, or maybe they're on holiday, whatever. Where are the backups? How do you know if the backups are already broken? Because if this attack actually started yesterday, then maybe your most recent backup is also useless. But how are you going to know that? How are you going to actually copy those over? How long is the copying going to take? Where are you going to restore the backup to? Do you have a server available to back up to? Are you going to have to turn the old server back on? Is that okay? Is that going to be too risky? Because that malware could then infect other machines on the network. Do you need authorization to do any of this? Who from? And of course, the problem with a lot of these questions is you might be going, I don't really know, but I'll find out. Well, it's easy to find out when the thing is not taking place, but while you are under attack, while your systems are down, you call somebody and say, can I have permission to do this? And that person goes, I'm not sure if I'm allowed to give you permission. I need to check with my boss, and my boss is in a meeting, and etc., etc. You kind of need to know all of this up front, because you need to be confident that when something happens that you are empowered to deal with it in a certain way, and that after you've done it, you're then not going to get in trouble for not asking the right person, or deleting something that you shouldn't have deleted. How long is copy going to take? What version of database software is installed? I don't know about you, but it'd be very likely that we're running Postgresql 14 in production, but Postgresql 15 is out. So if I just create a new server, is there a danger that I'm going to be running Postgresql 15? Because if I try and restore directly onto that, it's going to fail, because the files themselves are not compatible. I'd need to use a different method, which I don't want to do when I'm in the middle of a ransomware attack. So again, do I know that? How can I find that out? Do I know how to find it out? What's the command to run the restore? If you're anything like me, I'm always, even things I've done 1,000 times, I'm always scrambling around thinking, where did I write that down? Where's my wiki page that says this is the restore command? Your applications, are they going to be able to talk to the new server just with a DNS change? Do you have access to change the DNS? Did you suddenly realize that the time to live on the DNS is set to a day? So actually you're going to be screwed, because you're going to update it and your clients aren't even going to know, unless you then have to reboot those. So many things. How long is this all going to take is the ultimate the ultimate question. And the answer is, well, it could easily take several hours. Even if you know what you're doing, it could easily take several hours. In the case of some organizations, it has taken several days and even longer than that. So we've seen companies get attacked, and they obviously don't have a system in place to resolve these sorts of things, or they don't have the spare hardware, or they don't have things documented, or they were relying on something which itself has become unavailable as a result of the attack. And in a very few scenarios, it is possible, and it has happened, where you've completely lost the entire system. You have no backups or no accessible backups, or the backups don't work, the restore command doesn't work, they're based on an old version of the database, etc., etc. Lots of different scenarios where you've literally had to remove a system and delete it and say, that's it, I can't run this system anymore because we can't recover the database. Now that's pretty drastic, but it's not a million miles away from where most of us sort of run our systems from, just because we don't spend this little bit of time. Working hours, that might be fine. What happens at weekends and nights, or all of these things that you can ask yourself, and go through a number of scenarios. There's lots of things you could ask about. Ransomware is one scenario. What about disk failure, network failure, hosting provider failure, a problem with the upgrade? What happens if you upgrade your database servers from 14 to 15? And there's a bug in 15, it doesn't work. What are you going to do? Can you go backwards again? Is that a risk? How long is that going to take? So there's lots and lots of ways in which this recovery time could be very, very significant. And then the next question, of course, in a very similar way, is what point am I going to be able to get back to? Obviously, the closer to when the system went down, the better. So, and it is possible to get 0 point in time recovery. You can basically say I've lost nothing, and that's not just by writing logs as quickly as you possibly can. So I think in our main production system at work, our SQL Server one, we basically ship the logs every minute from SQL Server, so our RPO is usually less than a minute. But that's not to say the recovery time isn't significant in terms of failing over and things like that. But we probably keep fairly good amount of data, but we don't have 0. And in our system, a minute's probably okay, but 0 would be better, right? But again, do you know how recently you could go back to if you had a complete critical problem on your system and your live data was just busted and you needed to restore from a backup? It will depend on the type of system you're using. Maybe on a kind of low traffic website, maybe you wouldn't really care if you lost a day's worth of stuff. Maybe that's not very much stuff to lose. Obviously on a high traffic site, that could be an enormous amount. And I just want to share very quickly a video which I'll put in the link, which is about GitLab accidentally deleting the primary database. So the problem was they only had one replica. The replica was broken, and in order to try and fix it, an engineer wanted to basically delete the replica and then do another backup again. But he accidentally deleted the primary and not the replica. So of course everyone panicked, and they were like, well, what about the backups? And then they realized the backup job hadn't been running, and everyone obviously went, oh my goodness me, what's going on? What about the virtual machine backups? No, we don't do those on the database servers because you're supposed to have backups. Okay, that was a bit bad. And in the end, they found that they had a staging version of data which had been copied from production, fortunately only 4 hours before they had the outage. So that was lucky. That definitely wasn't their great planning. It was just luck that they had a 4-hour-old replica. But even though the RPO for them was quite good, 4 hours, for a catastrophic problem is not unreasonable. However, they had to copy it from another site, and that took 18 hours to copy, and then another 6 hours, I think, in order for them to actually bring it back online, test it all, create the replica, etc., etc. So they'd effectively probably done a little bit of risk analysis, but they hadn't looked in detail enough at all of the various failure modes. And even, obviously, the most obvious of all things is checking that it's actually working. How did you not know that your backup process wasn't working? Because that's your lifeline, and if your lifeline's broken, then you're dead, aren't you? Now, I must admit, I remember feeling quite smug when I read that. I thought, oh, those crazy guys, we've got a cluster, and we've got these replicas, and we've got the backups, and we back up from 2 databases where, we're the bee's knees. And I went and checked that backup job, and it wasn't running. It was running, but there were errors in the backup, so they weren't actually being taken. So our most recent backup at that point was 6 weeks old, which in our case was not terrible because of the system we were backing up. We probably rarely need to restore from a backup. We could probably just recreate the database, it would be fine. But in that case, it was just that warning of make sure if it's kind of not working. And there's various other things. Again, I don't want to sort of go on for hours and hours about this, but you're probably clever enough yourselves just to sit down with the relevant people and saying, what are the dependencies, what things are going to affect either my recovery point or my recovery time. Does the recovery depend on one person who knows something that nobody else does? A password they have in their password manager that no one else has. Do you have playbooks? So you don't have to remember what the commands are. You can just copy and paste them from a playbook. How do you test that every time you make an update that the changes haven't broken things? I mean, it might seem a silly thing, but what you don't want to do when you're stressed and you're trying to get a restoration happening and you see a random little error on a command that's supposed to work, well, yeah, if we weren't stressed, we could probably find out quite easily what the problem was, but maybe there's a version number in the command somewhere and that version number's been updated. So have we tested it since that's happened? What tooling do you use to make changes? At GitLab, they were just doing stuff in a console, in an SSH window, which was kind of terrible. But actually, the tooling itself can help reduce risks, but it can also add different risks. What happens if you change the version of SQL and the GUI tool doesn't work anymore, or a password gets broken and all of a sudden you can't connect? There's so many ways in which that itself could present risks. And as I mentioned before, what you're using to monitor to make sure that things are working properly. I'll show you a screen in a little while, which kind of shows an example of something that we now monitor after those previous backup failures to make sure that we're not missing when something really bad has gone wrong. And the biggest question of all, have you ever even tried to do an actual recovery from a backup? It's the silliest thing, and it should be the easiest thing. If you've actually designed in recovery as part of your business, it should be the easiest thing in the world. You obviously don't have to recover it to production, but if you even tried to recover just to a random temporary server just to make sure it works, how long does it take? Most people, don't have any appreciation. Imagine how long it takes to copy 500 gig over the network. Even within the same network, that could take a very long time. And if you do that and then something goes wrong and then you have to copy it all again, that might be another 10 minutes, another 20 minutes each time. So trying it's really, really, really crucial. I did read this quote. I can't remember where it was. I thought it was in the Barman docs, but I can't find it now. I read today, which was, only 50% of organizations had any kind of disaster recovery process. Half of businesses, bearing in mind that most businesses would go bankrupt if they couldn't recover their systems, right? Only 50%. And only half of those who did had only implemented one because they'd experienced a serious outage and realized they needed one, rather than realizing you need one anyway. Don't wait until it goes wrong, because then you're gonna look bad to your customers. You're gonna potentially lose data, lose money. And then half of the businesses that do test once a year or less. And I suspect most of those people are probably less, because I've worked at places which by ISO accreditation should be testing regularly, at least once a year, usually once every 6 months. And I've worked at organizations which tick that box to say they've done it, even though they have never done it, just because it's either risky or difficult for them to try it out and they don't want to, but they don't want to lose the accreditation, so they just say that it works, just to tick that box. So what the one I found interesting was everyone surveyed in this this quote that I ended up finding something equivalent. It was taken in 2021, but they said every single one of the people who responded said that they had found issues with their policy, and no one said, 0 people said that their test was moderately or completely successful. So the truth is, even for the people who have a process, they usually don't work. So thinking about these things, doing that paper exercise, sitting down for a few hours and just going through some scenarios, looking at your single points of failure, looking at where your data's stored, things like a data center being out of action, it's unlikely, but it's not actually that rare. What about if it's out for an hour or 2 hours or 4 hours or 8 hours? At what point do you have to treat it like it's unrecoverable and therefore set up a new system in a different data center? Are you even able to do that? If you have a replica set up, that might save you a ton of time because you just have to fail over, which is much easier. But obviously that doesn't solve problems with things like ransomware and stuff like that. So just need to kind of spend some time thinking about that. Right, let's move on quickly. I think only 3 slides here about backups. If you go and look at the PostgreSQL manual about backups, it kind of splits it into 3 areas. Now it's a little bit confusing because there is something which Postgres doesn't really talk about, which Barman supports and which we will be using. And the reason Postgres doesn't talk about it is because it's effectively shipping backups by pulling data from Postgres like you're a database replica, which is what Barman does. Now the reason Postgres doesn't really talk about it is because it's up to another application to pull that data. It's not up to Postgres. Postgres can push data, and you can call a client application to get a local backup or whatever, but in terms of actually automating that, the streaming side of it, which is creating a backup via the replication protocol, is not really mentioned at all. Anyway, the first thing we just need to talk about, again, we have mentioned these before, the write ahead logs, or just logs if you want. This is what's really, really critical in order to get a backup to a point in time. And that point in time might be now, but it might be a point in time saying I need to find out what was in the database in the middle of last week or whatever. And the point in time is effectively achieved by taking a base backup as a fixed set of consistent data, applying a number of logs to it up until the point in time you want, and then that produces the final state, which you can then recover from to a database, either into production or in some cases just onto a temporary server so you can look something up. So the logs are really important, and a lot of what we talk about in Barman is related to these logs, because the actual base backup thing is relatively straightforward. But the point in time we can only do if we have those WAL logs. And also it's quite a clever way of the way that Postgres does a base backup, because obviously that could take an amount of time. It could take a minute, could take 10 minutes. At what point is that backup consistent? Because obviously stuff that I read right on minute 0 is going to be different potentially when I'm up to minute 10 reading a different table and writing it out to my backup. So what it does is it takes those logs at the same time as it's doing the main backup. It then applies all of the logs once it's finished, and then that's the point where you get a consistent backup. So it's consistent at the end of the backup, not at the beginning. So the three that Postgres talks about, we're only going to talk about the third one briefly. So the first one is basically a logical backup. So this is kind of the oldest and perhaps the kind of dumbest way of taking a backup. You can use Postgres dump or Postgres dump all. They're mostly similar, but they do things slightly differently. But effectively it's a bit like MySQL dump, if you've ever used that. It writes the logical data into what is effectively a series of SQL script files, either to local file system or, obviously you can pipe it to whatever you want to pipe it to. But the key here is these aren't really very useful for recovery. You can't really do crash recovery. You only really get a line in the sand that says at this point in time this table was in this state. And unfortunately, if you use PG dump all, then you actually get each individual table at a different point in time, because it does them one after the other. So you don't actually get a completely consistent view of the database using these logical backups. The one main use for them is if you're upgrading a version of Postgres, you can't use the file system files because they're likely going to be in a different format with each version of Postgres. So instead you make a logical backup, which is going to require that you stop the database from accepting new connections and stuff, because you need it to be in a sort of static condition. Take a logical backup and then restore that into the new version, and that works fine, but no use to us in terms of crash recovery type backups, which is what we're looking at. The physical backups is kind of a bit like saying, well, if I want a physical backup and these things are no use to me, then why don't I just copy the files from the file system, because that's where the data is anyway, right? And the truth is you're never really going to do this, and the reason is quite simply that the file system is rarely in a known consistent state, right? The files get written all the time, they get buffered, they get cached, they get written usually as a background process to avoid adding a lot of synchronous delay to your or synchronous latency. So instead it writes them in the background, and so trying to get the file system in a state which means you can copy those files is difficult. Effectively you need to stop the database server again, and in production that's not really going to cut it much. But at the same time, back in the day, that was perhaps the only other option you had. You could maybe take a copy of those files. It probably wasn't great, and you had to really importantly make sure that you had all of the files you needed, because if you had things like table spaces, it's basically mapping another directory into the cluster. If you forget to take that directory as well, then you're going to be screwed. A lot of the time your cluster is going to be unrecoverable. So again, don't really care about physical backups in this context. The third one, which we're going to sort of mention briefly but we're not going to set up, is called continuous archiving. So if you remember, I said that there's something called streaming, which is a little bit like a pull backup, saying give me data please Postgres, and I'm going to create a backup from it. This is kind of the other way round. This is Postgres saying, I'm about to archive a log file, so I can call a script to do something with that log file. Now, that script could do anything. It could copy it to a cloud drive or, Amazon storage or something. But in our example, the way that would be used would be Postgres, a bit roundabout the wrong way really, Postgres telling Barman to come and get the archived file from Postgres and store it back on the Barman server. Now, why would you do that? Well, we'll look a little bit in a second at what the difference is between archiving and streaming. But effectively, in some scenarios, by using a file system level copy, which is what's really happening here, you get the ability to use something like rsync. And rsync allows you to effectively do incremental backups. If 90% of the files are not changed, you're not going to copy them because rsync knows that they're already the same, whereas only the ones that are changed are going to be copied. So in that sense, it can be very efficient in a networking bandwidth capacity, but there's a lot of extra setup, which is why I'm not going to bother doing that. So the continuous while archiving then is just to talk a bit about that third one. It's what we've already said. It's physical backup, allows point-in-time recovery. The streaming, which we'll talk about in a bit, is easy to set up. But because streaming is effectively just sending all of the log data as it comes in, there's nothing clever about it. It's just everything goes. So you can't do things like incremental backups and parallel backups, all the rest of it, because how would you parallelize stuff that's just coming in when it comes in? Unless Postgres managed to kind of split it up for you, it's likely just going to create a lot of confusion and a lot of error risk. So instead you just get one stream and you don't get to do any of the clever stuff. Now in most cases it's still easy to set up and probably still worth it. The only concern, as I mentioned before, is if you are massively bandwidth conscious, like going between two different data centers, which is not necessarily recommended, but if you are doing that, you might go, yeah, I'd rather use rsync and get a slightly less powerful but much more space efficient backup, then you might go with the archive method instead. You can run both. Most of the time there's no need to do that. If there was some reason why you might think, yeah, what if streaming stops working? It shouldn't. If you set it up right, it shouldn't stop working. You should know if it does stop working, but that's the only reason you might go, maybe I'll do archiving as well, just in case. And then in terms of actually the base backup, so we were looking at log shipping, but as I mentioned, the log shipping only works if you've got a base backup to apply the logs to. Otherwise you would just need to keep years and years and years of logs files, which wouldn't be efficient at all. So what can happen here is you call PG base backup if you were doing it manually, but Barman does this for you, and it's a little bit like saying, just send me all the stuff that I want in the form of a base backup. So it will already have certain logs, it will request other logs, it's already got a base backup, so it doesn't need to request everything, and then just using the data passed to PG base backup from Barman, it will ship over the relevant logs. It will tell Postgres to lock off the final log and switch to a new one, just so it can have a line in the sand to say, right, this is now the time and date for this. And then obviously it can then free up some of the log storage over time as the base backup is taken. Then effectively tells Postgres, I don't need any of the old logs anymore because I've now got a base backup. So then Postgres can clear up some of those old logs. Now this does require the most storage space because the logs are pretty large, right? They're a delta, a change over time. Now depending on the database you have, maybe stuff never changes, maybe it only gets inserted, in which case the logs are probably not too bad. Whereas if you have the same rows getting changed all the time, then it obviously would be much more efficient just to get the last state rather than every single change that got it to that point. But you don't have the ability to do that here, so you just have to get all of the logs and store them. Now relative to your database, we might be talking about a factor of maybe 20. So if you have a 4 gig database, you might need about 80 gig of disk space to keep 10, 20 backups. So that's the kind of rule of thumb. If your database is enormous, then this might be a problem for you and you might need to look at doing something different. So yeah. Which brings us, after all this time, onto Barman. Now, when we look at Barman, we want to effectively not have to do all this manual setup. So if you go and read all of the docs in Postgres about backup, it will tell you run PG-based backup and you pass it a path and you have to copy the file, you have to switch on the archive and do this, do that. It's a lot of faff. It's not difficult, but it would be easy to miss something and to not really understand. So effectively, we have something that's relatively easy to set up. We can put in a backup frequency, the type of backup to do, point it at the server, all that kind of stuff, which we'll go through in a little while. And then it kind of just runs and it just works. So you put in a retention period, for example, to say keep maybe 10 backups or keep 2 weeks worth of backups. And then after that, Barman will automatically delete the old ones so that your disk space doesn't get out of control. Now it is Linux only. I think it's written in Go if I remember correctly, but it might be Python, can't remember. But that's probably not a problem for most of us because it is like a command line thing anyway. I don't really see any reason why you'd want to run it on Windows. Linux machine's pretty small. It's open source, released under the general public license, the GNU license, so obviously all the usual caveats and GitHub repositories, all the rest of it. But it's really important that we install it on its own server. It's just a kind of a risk, right? If you put the thing that you need to recover your primary server on a primary server and the primary server gets destroyed, then you've lost the server and its backup in one go. So that's why you'd never really do that. Obviously, theoretically you could, but in this day and age, now that we've got cheap virtual machines and stuff like that, there's no reason that you should ever do that. And then you have to basically decide on your WAL shipping options. So we've already kind of gone over a load of these different things already, and sorry, those first 2 points I've already covered those anyway. But the idea is here you can either use the archiving process that we spoke about, so that is Postgres telling Barman to come and get a file from the file system, or you can use streaming. Now, one of the things that's kind of important about Barman is the WAL logs, as I mentioned earlier, are really flexible, really useful, because you've got that continuous timeline of activity. So if you said, I want to know what happened at 5 o'clock on Monday, if you've got log files covering that, then you can go and get that database at that point in time and you can see what you want to see. But clearly this is going to start adding up to a lot of disk space after a period of time. So what you might say, this is something that you might have seen on MySQL. I think it does something like this, and some of the rsyslog options, where it might say, yeah, I want maybe an hourly backup for one day, and then maybe a daily backup for a week, and then a weekly backup for a month, and a monthly backup for a year. So effectively reducing the amount of detail that you get the further back in time you go, but at least having something. So maybe I can't go back to 5 o'clock on Monday 6 months ago. Maybe I can just go back to last August or something. But maybe that's not a problem, and I'm going to save an enormous amount of disk space by not keeping a year's worth of logs. Unfortunately, Barman doesn't support that option. You can't say keep the base backups for a long time and the WAL logs for less time, which is unfortunate. The only way you would be able to do that is by setting up 2 separate backup jobs on Barman, and have one of them which is just taking the doing the archiving and taking those base backups, and have a separate one which is streaming all the logs, all the rest of it, and make one of them keep the stuff for longer than the other. It's kind of annoying. They might fix it in future versions, but yeah, there's lacking a little bit of functionality in that department. So whether you want to do that with all of the additional network bandwidth is kind of a question for you. But in most cases, streaming is the answer to which way do we want to ship this. If some of the things I've said have made you go, oh, I'm not sure about that, then that's obviously an exercise for you guys to go and just kind of compare a couple of them, maybe set up a proof of concept and just see what the difference is in disk space usage and network usage and stuff. But for now, we're just going to move on and say we're going to be using streaming. Now, in terms of actually choosing the hardware to run it on and where it's going to be, kind of nothing particularly weird here. Ideally, locally to the servers you're backing up. So if your Postgres servers are running in like the London data center, then it makes most sense for Barman to be in that London data center as well. The simple reason is the data transfer costs on a lot of cloud providers are extensive. Now, if this is on your private network, you host your own stuff at work, then the transfer cost might not be an issue for you, and you might have your own different redundancy patterns or whatever. But what you've got to think about is on a large busy server, you're talking about a significant amount of network traffic. So you'll just need to factor that into your thinking about where you want to put it, how close to the primary server, and therefore what your single point of failures might be. Because if that network switch goes down and you can't access your primary or your backup server, then you're kind of screwed, aren't you? Unless you've got a replica, but then all your backups are going to stop running. So you need to design that a little bit. But the separate fault zones on a cloud provider can be useful. So in most cloud providers, they have, 2, 3, 4, 5, depending on the size of the data center, supposedly completely separate fault zones, separate power supplies, separate backup generators, separate aircon. You get the idea. The idea being that the chance of more than one zone going down at the same time is very, very low. The truth is it does happen still, so you might need to take that into your thinking and just work out if that's a problem. But you can have multiple Barman servers, so you could have the one close to the servers you're backing up, and then you could copy everything to a second server. However, if you do that, again, you're going to potentially incur that additional data transfer cost. But you can choose which servers you do it for. You maybe say, I'm going to have Barman backing up 2 servers, but I'm only going to send one of those to the remote Barman server. You can also use hook scripts in Barman to send it to other places. So there's a whole load of stuff about setting up, blob stories in Azure or S3 in Amazon, and I think Google is the other one they support, GCP or whatever they call it. So you can push your data to somewhere else. It's just one of those things you need to think in terms of your kind of risk analysis. And one of the things for the cloud, high performance disks are ideal. Separate disks, again, if you can. There's just that nice sort of warm fuzzy feeling. Firstly, that the only stuff happening on this disk is related to Barman. I don't want my unattended upgrades to start running at 2 a.m, doing a load of disk activity and making Barman suddenly slow down and fall out of sync with the database service, for example. But the other thing is, if you do have to completely blitz your server with its OS, then that disk is safe because it's a separate entity in the cloud. You can disconnect it from one server and connect it to another. Just remember that in the case of Barman, by default, the Barman configuration and everything is going to be on the OS disk under the etc directory. So just remember that you'll need to have a copy of that unless you have a way to automate setting that up, which you might do. So installing is dead easy, and I'm just going to pop out of this in a second to show you what it looks like. I've already installed these on my Vagrant box by default, just to save some time. We want the Postgresql client package because we need some of those binaries to do, like base backup and stuff like that. We need cron because Barman works with cron. It won't install a service. It isn't a long-running daemon sitting there constantly doing stuff. What happens is every minute, Barman cron gets executed by cron, which is quite cool in a way because the system services bring in all sorts of their own risks. But here it just calls Barman, and Barman will look through its configurations and basically say, do I need to run anything that isn't running already? And that's all it checks. So most of the time it's not going to do anything. But if you've just enabled a configuration, it's going to go, oh, this one's enabled now. Let's start receiving the WoW logs, or let's start running rsync or whatever it is it needs to do. There is a master config file, which I'll have a look at in a minute. Most of it we don't need to change. It's got all the stuff like hook scripts and stuff, which we're not going to spend any time looking at. But it also creates this barman.d directory where you put your individual server configurations. and the parameters in these files override the global ones in this file. So you could have a global main directory, but you could override it for a particular server. Maybe it's a big database and you say, no, the home directory for this one is going to be on an external disk or something like that. So you can kind of override them, but you don't generally need to override that many parameters, which we'll see. And the defaults in the etc barman.conf, I think they're all okay. Certainly for our demo, they're okay. The only one that I'd recommend is setting to compression to be gzip. There's some other options, but that's just what I've used for now. Like most things, don't spend too much time overthinking it. Put on gzip. If you ever have a problem with compression, you can maybe spend some more time deciding whether the other versions are any better. For instance, you can set it to use like tar to actually archive the files using tar rather than just using the files themselves. I don't personally know what the trade-off is there. I suspect it means the restore will take longer because it'll have to, you know, untar the archives, but maybe that's not a big deal, and maybe that makes some of your stuff easier. I'm not sure. And it also gives you a couple of templates by default, which we'll go and have a look at, but we're mostly not bothered about those defaults at the moment. We're going to just create our own ones anyway. So let's just have a look at here. So we're logged in Vagrant into Barman, as you can see, and remember that most of these things actually run as the Barman user. So just to save typing sudo all the time, if we do sudo interactive as the user Barman, now we're logged in as Barman. So now if I edit any of those files, I can do it without sudo. The same in Postgres. If I do sudo -i-u Postgres, and now I'm there ready as Postgres to edit any of the Postgres files as well. So the first thing, let's look at etc barman.conf, and it's unwritable, which is fine. In fact, I'm not sure. That's interesting. So it's probably owned by root because it was installed by apt. It doesn't really matter at the moment. You can see here a lot of the stuff commented out, and like a lot of configuration files, they'll show you what the default is in the commented out line. So Barman home in the Ubuntu one is just the standard Ubuntu home directory for system accounts, ones that you don't normally log into, so varlib basically. Configuration files directory, again, if you were putting this on an external disk, you could move this onto that same disk, so that if you did have to blitz the server and create a new one, then you would retain this. So that might be pretty cool. Although yeah, I don't know how it would find this without the Barman comp file, so you need to make sure you copied that one anyway. Like I say, most of this stuff, it's kind of all fine. You can see here that it looks like the default is now gzip anyway, so that's actually fine. I think in the older version it wasn't, but you can see here there's some other options here, which again it's up to you to look at. The hook stuff don't really care about. You know, there's various things that might only be relevant for certain things. So for example, network compression is only relevant if you're using the archiving function rather than streaming, because it does something to the archive command to compress the data before it gets sent. So things like that, which again for this point in time we're not going to overcomplicate it. There's no point optimizing it because there's not necessarily a problem. So that's that. And if we look at barman.d, we'll see that there are a couple of templates in there. Now if you look at these, I mean, they're kind of, I don't know how useful they really are, because in most cases you're going to have to know what all of these parameters mean anyway, in which case I don't necessarily think that these are that useful, but they are there if you want to know. But the two that we're most interested in, if I look at the streaming one, is probably the closest to what we're going to do. The two things that are most important is this backup method. Now Postgres basically means use PG based backup. That's what Postgres is. If that said, I think it's rsync or maybe archive, can't remember what the other option is, would mean to go and do the archive process instead. So we're going to be using Postgres for that. And then the other one is how do we ship the logs, and you can see that the streaming archiver is turned on. In other words, This is using streaming for the logs, and it's using streaming for the base backups. So this is basically what our file is going to look like, very similar to that. And this green bit here is the name of the server configuration. Now that's important because we see that again in Rep Manager, where there's a parameter called like server, and it's a bit of a confusing name because it's not the server like a server name like Postgres1. It's whatever you've called the configuration in here, because in Barman this would be called a server. So don't need to remember that, but we will come back to that later on. So we've got all those things there. Let's just pop back to, oh, not that one, keep going to the wrong page. Sorry, where are we? Here. Current slide. So as I mentioned earlier, one of the things that we will need to do, we won't do it in this example because it's just even more stuff to kind of learn. The bottom half of this screen are all numbers that are coming from our production Barman server. These top ones are to do with replication lag, which is another important way of knowing that your replicas are working correctly, in that the lag here, which is in seconds, I think it's like 4 milliseconds. So yeah, those numbers need to be small. But here, if you look at things that we might want to monitor and why it's really important, the disk used, it's so easy. At one point that was up to 80%, and I didn't know what was going on, and the truth was we were keeping too many backups, more than we would ever need. So just by changing that configuration, that dropped down from 80 to 45%. The other lines down here are the actual Postgres servers, so we would expect to be using less, but the actual Barman server with all of its WoW logs and base backups and everything else is there. And these numbers as well are just a nice easy indication to say, right, we've got 11 backups of our main primary server, but why not have some backups of our main secondary server? Why? Well, because if we fail over to Postgres 2, then we can then have the flexibility to say, actually, I'm going to ditch Postgres 1 completely, but I've still got 6 backups, and I'll just increase the retention period for 2 and get that up to 11. I think it's actually set to 10, but it's got 11, and that's 5. But if I hadn't got any of these, and then I set up a new backup for Postgres 2 after failing over, then I would have no backups for Postgres 2 until that night time when it first ran, unless I ran one manually, of course. So that would immediately create us a lack of backups issue. Whereas, yeah, we'd have to keep the Postgres 1 logs around for ages. So there's a few little sort of weird things there which I kind of learned just to set up 2 of them and have them running in parallel. Obviously a lot of the data is going to be identical, but I can live with that. We're not using up too much disk space. This is another thing, failed backups. They obviously could fail for a number of reasons, mostly if you've done something like change the access rules on your primary server. I think that's why one of mine had broken. So all of the backups were failing, but I wasn't monitoring it. I didn't know. Whereas having this here, if I get fail 1, that number's obviously going to change, and then it's going to show me, I need to go and look at what's going on there. It's fine to have a failure because, well, it's not fine. Ideally, you wouldn't have any. But if you do and you know about it, you can fix it before it becomes a problem, right? Whereas if you don't know about it, you only find out it's a problem when something else goes wrong, and by that point, you're screwed. And the other thing is here, the last backup. So this was obviously taken on the, well, not obviously, it was taken on the 12th of May. And as you can see here, it's just demonstrating that these backups, which get taken at 10 p.m. every night, it's successfully backed up the night before. So that's the other thing. Yeah, I might have 11, I might have 6, but how do I know they're up to date? So I also show the dates, and this just as a sort of sanity check shows me when the first backup was taken. And this is Prometheus. This is a Grafana dashboard looking at Prometheus data. There is basically a Barman exporter project that you can use, which is what we installed on there. So the monitoring's so important. We have already looked through this. We're going to recreate something like this on our Barman server now, and then we'll kind of look at the various options, although we have kind of talked about them already. So let's just go back to here, and let's we'll create a Postgres 1 .conf. Oh, still wants me to do it with sudo, which is a bit annoying. So what I'm going to do, I'm going to just change that barman.d right, and then if I go back to there and try the same thing again, good, I now own the directory. I quite like doing things on the fly because I know that sometimes you do a demo and it all looks like it's really easy and all the rest of it, but when you do it in real life, it's things like that which you suddenly go, oh, what's going on, you know. So one of the things that can be quite useful is you can set active equals false. The reason it's useful is because you can still run the check against this configuration and it will still give you some sort of helpful hints about whether you haven't done anything properly or not. Description is just, you know, Postgres 1 server or whatever you want to call it. Coninfo equals, right, so host equals Postgres 1. Now we need to think carefully about this because we need to make sure that the Barman server knows where Postgres 1 is, and we'll find that out when we exit this. User equals Barman. Now we haven't created this user yet, we'll do that in a bit. The DB name, we're just going to point to the master database because it's going to be backing up the whole cluster, so we just point it at that one. So that's all we need for there. Now the streaming coninfo, you might think it's the same, but it isn't, for the simple reason that the user is different, and it's because the way you create a replication user is different than how you create a normal user. So again, we'll create both of those users in a bit. So we've got that. Now backup underscore method equals Postgres. So remember that's using base backup, and we can put a comment in there if we want. I can't remember what the syntax was. I think it might have been a semicolon, but I'm not gonna go there. Streaming underscore archiver is on, so that means we're going to also save the logs using streaming replication. The slot name, so slots is something we haven't really mentioned, but the idea of a slot is Postgres keeping tabs on which logs have been accepted by which replication targets. So if you've got, you know, you could have 10 replicas, right, and 9 of them might be fine, but the 10th one might be struggling to keep up. Maybe it's been rebooted or something. And the problem with the way that logs work on all systems, and particularly in Postgres, is eventually the old log files are going to get reused, and that's just to save the overhead of continually creating new files and deleting files. So the old files eventually get overwritten. So how does it know when it can overwrite it? Well, normally it doesn't. You would have to basically set how long you want it to keep them for, and then make sure that your replicas are always up to date, and if they fall too far behind, they'll become broken. The replication lag will just start going up and up and up and up, and you know there's a problem. But using slots, it enables Postgres to know that server number 10 out of 10 hasn't got the last 6 log files yet, and so it will hold on to them and not reuse them. So that's what we use slots for. We give it a name, and it's just whatever you want to call it, really, just something unique. And then something that Barman can do now is you can get Barman to create the slot for you so that you don't need to create it manually yourself, whereas back in the day you used to. And then the last thing is we can set retention policy. Now obviously in our case this is just a demo, it doesn't really matter, but we can put something like, and there are lots of different things you can put in here, both recovery window, number of backups, that kind of thing. You can go and look at the docs if you need to, but effectively this is kind of what we're going to do. So first thing I want to do before I forget is if I do that, it's found address 215, is that right? God, I hate these printouts. 1.2.15. Okay, so it does have this was the one that we were kind of normally using, but it's because of the network, the multiple networks that Vagrant uses. I don't really mind as long as Postgres is running on all the network interfaces, then that will run fine. So I'm happy that it knows where Postgres 1 is. Let's just zoom back to here again. So we looked at that. So we talked about rsync and SSH versus streaming. So in most cases, we're just going to do streaming. It's easier. We have to set up some users, but we don't really have to do very much else. And as already mentioned, the streaming doesn't support some of the cooler things that you might need for very large or very high traffic sites, like incremental backups and deduplication, stuff like that. If you are really sensitive to network time or bandwidth, you might want to look at the archiving using rsync instead. But there are some costs to that. For example, you're not going to get your 0 RPO, because depending on how long it's been since Postgres last archived a file, you might have an amount of data. It's probably not going to be a lot. The normal segment size is 16 meg, which sounds like quite a lot, but obviously that's 16 meg in total with all of the system information and everything else. So you're probably not going to lose a lot, but it could still be maybe a minute or two of data. You can combine them again, but we're just not going to do that. Again, we looked at the WAL shipping type. We mentioned this before. Streaming is in most cases a lower risk. That's what we've just put in our config file, and we can get very close to 0 recovery point. It depends on whether your replication slot is running synchronously or asynchronously. Now, what does synchronously mean? Synchronously means that when data goes to the primary and wants to be written, it will also be sent to and written to the replica before telling the client that the transaction has succeeded. Now, obviously, there's a latency issue there, and it could be significant, but if you wanted 0, then you effectively say, I need to make sure that that write has been persisted on my Barman server before I persist it locally. You wouldn't normally need that. Most people can afford to lose a tiny bit of data and would just use the asynchronous one, which is going to be almost as quick. You're just not going to make the client wait for it to happen. So as I mentioned, the RPO by default, if you use archiving, is about 16 meg. You can reduce that, but if you reduce it too much, then you can also potentially get a lot of overhead, because the file is still 16 meg. It just contains less data, so you don't save on the network bandwidth. You would just get the data more frequently. So a bit of a trade-off there. Like I say, in most cases, we're not even going to talk much more about archiving. So these are the examples we're looking at. We've got some archiving ones next, but again, this is scenario 1 from the Barman manual, which is where I took the images from. You've got your kind of PostgreSQL connection, those connection strings we put into the configuration. That's what these are for. And what they allow it to do is connect to Postgres server, ask it questions, set up slots, do various bits and bobs, and then you end up with these 2 streaming connections. One of them does the base backups when you do a backup, and the other one's constantly running, which is streaming the logs. And this is just an example of how you might run an SSH connection as redundancy. Honestly, I don't really see that you're really solving many problems by having both. I could see why you might want the red one with SSH instead of streaming, but I don't think you'd really want to have both. But hey ho, you can if you want. And then the next one's almost the same, just in reverse. So you still have the management connection, but you are now using SSH for backups and SSH for the logs. And again, don't really see why you would do that. Set up streaming as well as an additional thing. So yeah, these are the sort of scenarios. So there is an SSH setup which might be needed. If you're using archiving, you have to set up SSH because that's how it works. In the case of backup, then Barman needs to be able to connect to Postgres. So that's Barman talking to Postgres. But in the case of the archive, Postgres needs to talk to Barman. So I don't really want to spend ages talking about SSH. I'm sure you all know how it works. But it's obviously your SSH keygen, all the rest of it. Bearing in mind that some of the newer versions of Ubuntu don't support RSA keys by default anymore, or maybe RSA keys of 2000 bits or less, I can't remember. But nowadays you tend to use the ED 25519s, nice small keys, and yeah, they're acceptably strong. So all of the usual SSH stuff, but we're not going to do that because I don't think we need to. Although I always have in the past, so I reserve the right for something to not work properly if I realise that I do need it. So this is going to be some streaming setup. So what we talk about here, replication user on your database, we'll call it streaming Barman, and then a normal user called Barman. Streaming needs replication. Barman needs to be a super user. Now we need to check the password format on the server before doing this. We'll need that for the PGHBA conf thing we'll see in a minute. And then we're going to use pgpass, which we'll show you in a second, to store it on the Barman server, because then we don't have to have it inside the normal configuration. So if we go to, we're running Postgres here. So what we can do, we can either do it just using the -c. So we can do psql -in. You can just run a command directly in there. I might just be clear that I'm using my local user, which I think it does by default. So what we could do here, I need to always forget the syntax for this. So I'm just going to bring up the old Postgres create replication user. It is actually mentioned in the Barman docs as well, and I thought I had pasted it into the PowerPoint, but I haven't, so tough luck. Let's just find one of these, and then right, so we are going to do create role. Now role is like a user which doesn't have login permission, so we're going to have this, we're going to call it streaming Barman because this is the replication one, with replication, so that gives it the replication permission, and then password, that's going to be annoying. I'm not quite sure which quotes I'm going to be able to use here. So if we just do a password like password123, I don't need to tell you that that's bad. It's come back with create role, so that hopefully means there wasn't an error with that. So that's fine, and we'll create another one, another user. This time we can do user, so that will automatically give it login, but we also want this to be a super user because the Barman user is going to want to do various things, set up replication, etc, etc, etc. So I think that is also what I need. So that's all good. There is actually a slide somewhere I've got to test this later on, so that's probably where it actually has the thing. So the next thing we need to think about is a pgpass file. Now pgpass, if I just make sure I'm in my home directory, pgpass is effectively a way of saying, a little bit like they do with Amazon credentials and stuff like that, rather than putting them directly in this postgres1.conf, which might be a file that's under source control. Instead, I can put them in pgpass in a file locally. That would have broken. File locally in my home directory. .pgpass is the file name, in a certain format. And if I do that, then when Postgres by default tries to connect to a database, it will look in this file for passwords and port numbers and stuff like that. So the general syntax is host, port, database, user, password. Right? It's as easy as that. Now you can put stars in there. So for the time being, because we've only got one cluster and one set of databases all going to be the same, we can do that. I'll put 5432 just so that something weird doesn't happen there. For the database, I'll just say star because whatever it wants to connect to. Oh, because I keep highlighting stuff, doesn't work in Nano. The user, we've got two users, so one of them is called Barman, and we did, what did we do? Password 123, and if I do Control K, Control U, and Control U, I can also do the same connection for that as well. Okay, Control X, yes, bang. Right, so that should be fine. Now, while we go back to postgresql.conf, we're going to need to check the access file to make sure that Barman is going to be allowed to connect to Postgres. Now, the nice thing about the way that the access file works is you do get an error if the problem is with the access file. And I really like that. I know there's a tendency for people to kind of say, oh yeah, you should hide the error messages so people can't hack it and blah blah blah. So you know what, that's nonsense, because if it's the access file preventing me, then I've already been prevented from getting in. So I don't, it's not helping an attacker, but it is helping me. So if we go back to here, we're logged in as that. So let's go to Cetra, Postgresql, and we want to go to the main configuration file for Postgres. So we will be changing pghpa conf, but while we're here, we just need to check a couple of things. So Control W in nano is where, and we look for this, and you can see that by default it's set to replica. That's, like I say, it's commented out, but it's set to replica. That's fine. That's what when it's set to. If you want, you can uncomment it just to be explicit, which is also fine, but I'm not going to bother for this. We're also going to look for Maxwell senders, and you can see it's set to 10. Now this is how many processes will be started to send logs to somewhere else. So in our case, 10 is plenty. If your cluster had 15 replicas, then you would need at least 15 plus your Barman server plus maybe a couple of spare. It's obviously a sanity check. I mean, you could put 200 in there if you wanted to, but obviously if a bug caused loads of replicas to start up for some reason, then they're likely to make this thing fall over. Whereas, if you put a sensible limit, then you'll get an error message saying I can't set up replication because Maxwell senders has been exceeded. There's also the max replication slots, which by default is going to be set to the same, set to 10. So again, that's all fine, which means I'm happy with that file. Don't need to change it. And the other one is pghba. So we looked at this in one of the last videos. You can see at the minute we don't have very much in there. So this is where we need to kind of add in our, Barman entries. Now, this does get really confusing. I normally have to look these up if I'm honest, but the first one for Barman, I think, is only for the database Postgres. The user will be called Barman. Now, this is where I've got to be careful, because remember, it wasn't the IP subnet that I thought it was. So if I get my right, what did it say? It was 168.1.215. So I am 192.1.171 by the looks of it. So I'm gonna keep forgetting this is PowerShell, so I need to copy that, paste it there, and remember we need SIDRs. And I think that my server, that was what I was going to look at. I think it's actually that, but I think it should be backwards compatible, so I'm hoping that doesn't matter. And then what we're going to do is we're going to do host, and this time it's a special database name called replication, and this time it's the streaming Barman, and we will also paste that in there, 32, and then we'll also do scram SHA-256. Now I just want to double check that I've definitely got that right, because just making sure. Right, scram SHA-256. Just want to make sure it's the right thing. Yeah. I think I'm pretty sure that's what the server's set to already, so that hopefully will work. I think that's all I need to do, so let's just exit that. And then what I need to do, Postgres isn't sudo, so I have to log out with Control D and just do sudo service PostgreSQL reload. So that now should hopefully have taken effect. And now what I can do, if I've done all of this right, I can basically yeah, sorry, I'm just looking at my notes here. The other thing to note is that when we set up the replicas, we're going to want to have the same contents of these on all of them, because what we need to remember is something might be a secondary now, but it might become the primary, and Barman might need to connect to it to start backing up the primary, the new primary. So that's one of the reasons why we try and keep everything in sync. But if now I'm still logging as Barman, which is fine. So if I do psql, and the command I'm just going to run is select version, and just to be clear, I'm using my Barman user. The host is Postgres 1, and the database is going to be Postgres. Right, here we go. So, blah blah blah. Warning: password file has group or world access. Okay, so what it's probably telling me is it's not going to use the password one, because the password file, because I didn't make it restrictive enough. So 600.pgpass. Right, what about now if I do it? Right, let's just double check this. So that's what, as I said earlier, it gives you a nice useful error message. So let's just go back in. Oh, I need to go back as Postgres. Do that again. Right, what's it telling me? No, for host 102.168.1171. So that's definitely correct. User Barman, database Postgres. SSL on. And then it says no entry for host of the user Barman database with SSL off. Right, so what I need to just double check is whether my that's what happens when you delete all of the help comments. Make sure that I've got database and user around the right way, because if I haven't, so yeah, database user host Postgres, the user's Barman 192.168.171/32. So the other possibility is that I've used the wrong thing here. So let's just try this as well. Right, let's try this again. Okay, so you can see here that it's returned some data, so the query's worked. So that's interesting actually, that I thought that my server, in fact I'm going to go and check because I'm suspicious now. If we go to this one, there is actually a I don't know what the thing's called. Maybe oh, it is MD5 by default. I must have been looking at a different server. I thought I looked at this the other day and that was set to Scram SHA-256. What the reason it matters is, depending on what this is set to when you create the password, that's what the line in PGHBA conf needs to be. So even if I change this now to Scram SHA-256, I think it might still work because I think it's backwards compatible, but it might not work, and I might need to set the passwords again to pick up the new type of password auth. So anyway, that's kind of fine. That's nice because it's basically showed me something useful, and it's sort of come out. Now, how do I test the streaming one? Well, I have to do something slightly different here because I don't actually have direct normal access to a normal database. So I need to tell it which user to use, which host to use, which is just Postgres 1. And then the command I'm going to send is identify system, and then replication equals 1. Right, role streaming Barman is not permitted to log in. So I'm wondering whether, although I saw a thing that said create role, I'm thinking that perhaps I should have actually created that with login as well, like a user. So that's fine. What I'll do is I'll go back into where I'm Postgres already. So psql, the command I'm going to do is, oh my goodness me, alter role. Don't know how to do this, to be honest, and find out. With login. I have no idea if this is going to work. So what are we doing? Dash U. I'm gonna log in as Postgres. Is that going to work? I don't actually know if this is going to work. Oh, it did work. Oh, more surprised than you. Okay, so there's our command there. Again, it's in the notes of the PowerPoint. Tell it to use the streaming Barman user. Tell it to point to our primary. We're going to call identify system. I have no idea what replication equals 1 means. But you can see here that, okay, there's some stuff, a timeline. That doesn't mean anything to me, but I know that at least it's working. So we're kind of back there. Okay, so we've already set up our Barman conf for Postgres 1, our conf file. So we saw that earlier, didn't we? If we just do, let's just cat it for want of a better thing to do, barman.d. Okay, so there's not a lot in there. Active is false, blah 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 blah. But the first thing that we can do is we can basically run Barman check, and don't panic when we do this, and there'll be a load of errors. Right, so WoW archive has failed, replication slot is failed, but that's probably failed because the WoW archiving hasn't been set up and receive WoW isn't running. Now it does tell you to do a number of things. So here, like Barman blah 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 blah. So you can try this, but I suspect it won't work. So if you copy that and paste it in, skip an inactive server. So it's inactive anyway. When you think, well, if it's inactive, I'm not sure whether those things are going to work. But actually, most of the other stuff's green anyway, and the log shipping is not running, which is not going to be because it's inactive. Replication slot says it's failed, but maybe it's not going to be active because we're not running. And the WoW archive, it says please make sure the shipping is set up. Well, we'll talk about that one in a minute, but the first thing I want to do is just edit this and set this to be true. Oh, I don't know what I did there. In a sec. Oh, that's what I did. So let's try again. Right, now if we run check, oh, it's not check, what do we do? Receive WoW. Right, so now that the job is actually running, you can see here I've told it to create this slot on Postgres 1, and you see it said creating replication slot Barman 1 PG. Remember, that was the name that we gave it on server Postgres 1, and it's worked. Okay, so that's pretty good. If we run it again, okay, it's still showing it's failed. Now what's going on now is it's created a slot, but there isn't a log file for it to actually archive. Now the reason is our database isn't doing anything, so there's nothing happening, right? So what we can do is we can then force it to actually switch a log file in order to get something moving, even if it's just the first one. And what we do now, all of these need to be run as the Barman user. So I'm obviously logged in using sudo, but just be careful that when you run things, if you're running it as your Ubuntu user or whatever, you try and use sudo and things, it all goes wrong. So just try and make sure you're always doing this. Right, what happens now? So you can see here, it's told Postgres 1 to close the current archive file, even though it's not full up or anything. And now it's going to wait for 30 seconds for that to be shipped over. Now don't worry if it times out, because sometimes it, for some reason I don't really know, yeah, there you go, eventually works. So eventually somehow some things happened, it set up, and then it processed it and it archived it. Now what does that mean? Well, hopefully it means now that when I check Postgres 1 that everything's okay. They're all green. So just remember that when you first run Barman check, you can get some errors which are not actually errors. They're just things to say, well, it's not running yet. And the answer is, well, I know it's not running yet because I haven't made it run yet. The switch while one is only usually important on quiet databases. If I did this on my production database, it would be writing those wows fairly regularly, and it would have picked that up pretty quickly. But in this case, obviously, I'm not doing anything on the database server. There's nothing for it to write. But you can see here that it's kind of worked. And what I want to do is, so I'm in my home directory. So if we now go and have a look in here. Oh, there we go. So I put a /. So you can see here it's created a directory structure. This is under the Barman home directory, which is where the stuff is put by default. So incoming is where the logs are written to as they're effectively copied directly. And then once they're archived, they get archived into the wows folder. So if we look at incoming, it's now empty because we've archived the file that came in. And if we look under here, we'll see that that's the file that we just saw, that it said I'm going to archive it. It's archived in there, and it's whatever, xlogdb. Now if we look at the base directory, there's going to be nothing in there, I suspect, because we haven't run a backup yet. Okay, so let's just go back to the notes a second. How do we do a backup? Well, the backup is as simple as Barman backup Postgres 1. Now the cron job that's installed by default, that I said earlier, is running Barman and going, do we need to run anything up? Do we need to do anything? That has nothing to do with scheduled backups. All that's going to do is make sure that log shipping is running. So if you want to run backups on the schedule, you have to add them using cron tab -e. Obviously there's all things around setting up mail for cron. You know, what happens if you fail over to another primary? As I mentioned before, I back up 2 servers so that if I do fail over, I'll always fail over to Postgres 2 first if I can, keeping those backups in parallel, and then usually fail back to Postgres 1 if I can as well. So that's something you'll need to think about, how that's going to work, how it could be automated. So we'll have a look at the scheduling in a second, but obviously won't really be able to prove very much. But then the important thing is we need to test everything. Now you could see here that what we did wasn't really harmful for the primary server. We didn't need to restart it, but we could have done. If you needed that WAL senders to be like 50, then you're going to need to restart the database. So you need to be careful about what that might mean, whether you need maintenance downtime or whether you're just going to risk it or whatever. That's obviously up to you. But mostly this is a fairly painless and a fairly non-breaking change. But the other thing is, we will look at this a bit later. We should, once we've done this, we go, oh yeah, it's great, we've got all our backups, it's wonderful. We should then run through a recovery process before we trust it, right? It's all very well saying I've got backups. I mean, I've got backups on that screen, that monitoring screen. But I've no idea whether they've worked, whether I can recover until I actually try it. And one thing that's really important is you don't need to, and in most cases you shouldn't recover directly to the production database, only in the scenario that you're doing it for real. But most of the time, even in production, it's much easier to restore it to another fresh server and then to switch that one in as the main primary and then switch out the old one. Then you might want to keep the old one. If there's a problem, you might want to debug it and all the rest of it. Just remember to make sure you take it out of any kind of load balancer set. If you will need to use the point-in-time recovery, make sure you've tested that as well. It's kind of part of the same command, but you might need to get used to how you specify the timestamps and all the rest of it, just to make sure, again, that when you need to do it quickly, that you're going to be able to do it quickly and not be flapping around trying to work out why your timestamp doesn't work. And there is an overlap here when we talk about recovery. Rep Manager is designed to create replicas. So if the server is broken but the data is otherwise okay, in most cases a failover will be preferable, because you flick a switch, number 2 becomes the primary, number 1 either becomes a secondary or just you shut it down, and that's quick, that's instant, and you're not dealing with Barman at all. However, if the data itself is broken, then the chances are you're going to need to go back in time to a certain point and recover from there. So you might need to do everything. I'll show you the backup in a second, but I'll just finish my kind of last slide really. I'm not going to go into any detail. I'm not going to show how it's set up, but you can have multiple stores of backups if you want to basically make Barman a geo-tolerant. You can create other Barman instances. You can have everything pulled to one and then send all of that to another Barman. You could even use rsync on the second on the backup one, which then might be more efficient than just streaming everything directly to it, but that's kind of up to you. And you can also, like I say, you can stream stuff from Barman directly to cloud storage if you feel like it, or a cloud provider like Azure might have geo redundancy options. They might automatically copy your data from a storage account just so that it's available. But again, don't just do that for the sake of it. You then have to think about, well, what happens if I lose my primary Barman server? What would I actually need to do to get access to these geo-redundant backups? What am I going to put them on? How am I going to restore them, etc.? So there's more to it than just having the data, but obviously having the data is the most important one. So let's just finish by kind of showing the backup process. Like I say, backup's dead easy because all you'd have to do, again, running as the Barman server, Barman, backup, and then the name of the configuration, and then all you do, now in this case the database is so small, you can see backup size is only still 30 megs somehow, but you can see not only is it backed up the database, it's also warned you that the configuration files are not backed up as part of this. So if these are not files that you can get directly from automation or source control or whatever, then you should consider backing those up separately as well, so they can be restored at the same time. And now that I've done that, if I do Barman list backups for Postgres 1, oh, what did I typed it wrong? Sure it was, oh, list backup. You can see that there's one backup here, total size 47 meg, and no log files. And the reason is because we archived the most recent WoW file. The database would have been checkpointed when we did a backup, and nothing's happened since then, so it's not surprising that there are no logs. If I did another backup, again, it's going to do the same thing, but what it's realized is, well, hang on a second, there's nothing actually happened since the last time, so we're going to set it as waiting for more log files. And like it says here, you don't necessarily need to worry about that, and it says Barman will automatically set it as done once any more WoW files have been archived, but you can do it synchronously and wait for that if you want. And if I can do that, you can see there that they're both kind of present with a timestamp and an ID and everything. So that's cool. And if you do want to schedule it, then all you got to do is use good old cron tab. I'll use Nano, and then like it says here, it's, you know, got some examples of cron tab generators on online and stuff. So you could say at 0 minutes and maybe 10 p.m. every night on every day of the week, then Barman backup Postgres 1, easy as that, 10 o'clock every night. Obviously my one's not going to be running because they're just demos, but there was a lot in there. However, most of it was introductory, most of it was about risk analysis. The actual configuration of Barman was pretty simple. There's a little bit of stuff to do here, but some of that might have already been done depending on how you configure your access file. This server might have already had access to it anyway, but 2 lines in there was all it took. A couple of users created a PG pass file, which we saw here. cat.pgpass is just that, and that's all it took. We've now got backups, we've set up a regular scheduled backup, and what we're going to look at in the next video is Rep Manager. So in Rep Manager is effectively a tool that's designed to set up replicas, but also to control failover scenarios. So Rep Manager works nicely with Barman, so it will get the data it needs from Barman to create the replica. So that means it's very easy on the main primary, which has got enough other stuff to do. And then the failover process allows you to say, right, make this new one a primary and tell all of the others to start following me as well. Now, Rep Managers is going to have a lot less explaining because there isn't really a lot to explain, but there's quite a bit more setup because you have to set up all the SSH commands and things like that. So I will probably edit the next video because there'll be a lot of repetition. But by the end of the next video, we'll have 2 replicas running in sync with the primary, and then we can demonstrate some of those things that we saw with, to show the replication lag and things like that, and probably introduce pgadmin as well, because sometimes it's a bit easier to see what's going on in a GUI tool than it is on the command line. So this was long, but hopefully it's been useful, and I will see you in the next video.